Hi everyone. Firstly, I have to apologize for the lack of updates this few days because last week was the school holidays, so it was a pretty hectic week for me. So therefore, there was a delay in the updates. So over the next few days, I will try my best to cover a few more questions such that we can cover those that we have missed. Okay, so today let us look at this question. So this question is about guessing the rate law given the mechanism of the reaction. So ozone in the Earth's atmosphere decomposes according to the following equation. 2 moles of O3 ozone is decomposed into 3 moles of O2 gas and is thought to occur via a two-step reaction. In step 1, which highlights is the first step and is reversible. 1 mole of ozone will decompose reversibly to 1 mole of O2 and 1 mole of O. And then in the next step, 1 more mole of O3 will react with the oxygen atom from the previous step to give you 2 O2 molecules. So which rate law is consistent with this mechanism? So for this type of questions, we know that the rate of the reaction is dependent on the slow step. Because the slow step being the slowest, it is the bottleneck for the reaction. Hence, the rate law is dependent on just the slow step. So in this case, this is the rate equation that we have. Rate equals to K times concentration of ozone times concentration of oxygen atom. So we have learned that I cannot have intermediates in my rate law. So no intermediate in rate law. I can only have reactant. And I know that the intermediate because it was produced in step 1 and used up in step 2. So over here, I have to change my intermediate to a reactant. So then we have to see where did my oxygen atom come from. So it came from step 1, which means it came from 1 mole of O3. So usually that's it. We put that as our answer. However, over here, this question is not so simple because it's a reversible reaction, meaning that you don't know where the point of equilibrium lies. You don't know how much to the left or how much to the right it is because it's not complete. Hence, therefore, it is a bit more complicated. So, well, we know that Kc is equivalent to concentration of O2 times concentration of O over the concentration of O3. Why are we calculating Kc? Because I know that Kc is an expression which tells me about the extent of the reaction, the point of equilibrium for the reaction. So over here, I can do a cross multiplication and I realize that the concentration of O is equals to Kc times concentration of ozone over concentration of O2. So since step 1 is reversible, and therefore I don't know to what extent the reaction is occurring, so hence I will make O the subject and I will substitute this into my concentration of O. So then rate equals to K times Kc times concentration of O3 squared over concentration of O2. So K times Kc, well, both are constants, therefore I can just merge them into a new K. And then the rest stays the same. So which one matches this? It will be A. Therefore, the answer is A for this question. Hope that all of you have understood it. So take note, the main idea is that if it's a reversible reaction, you have to take note to what extent does it occur. And to do so, you have to use the Kc to help you to calculate. Thank you so much for watching and have a nice day. Bye bye.